Okay, so we are going to be looking at X and Y intercepts. We're going to use those to help us graph, and we're also going to be able to interpret what it is when a line crosses the X or meets the X axis or the Y axis and what that intercept means. So let's look at an example. We've got this graph over here of, hang on, oops. 1 second. Why can't I get my pen? Okay, there we go. So we've got this graph over here that shows us over time, and of course because that's time, that must be our x-axis. I'm going to extend it over this way just a little bit so you realize that that's actually an axis. And this is elevation. The reason I'm only in the fourth quadrant is because there was positive amounts of time, but negative elevation. So I'm over here in the fourth quadrant. But what you see is over time, I have ascended or gone up from negative 120 feet all the way up to when I'm reaching the air of sea level or whatever it might be. So notice here is my x-intercept right here at 4, and what that means is I've now come back up to the top of the water and I've reached the surface. Down here my y-intercept shows me the furthest down, the deepest point that I was in elevation as I was in my dive. So this is where I started at negative 120 feet. I ascended until I reached the surface at 4 minutes. So at 0 minutes, I was at negative 120 feet. At 4 minutes, I'm at 0 feet. Okay, so my x and y intercepts. I can now see on the graph how easily I can identify these points. Here I'm crossing the x right there at negative 2. So my x-intercept is at negative 2. My y-intercept is right here at a positive 1. So by looking at the graph, I can see my x and my y intercepts. All right, so I'm going to try to find the x and y intercepts for this equation written in standard form. Remember, it's ax plus by equals c, and obviously I have a plus negative 2y. So the first thing I'm going to do is find my x-intercept. So to do that, I'm going to replace y with 0. Remember when I had my, grab my pen. When I had my y-intercept, my x-intercept, I was at the point 4, 0 on the last graph, remember? At the point 4, 0 on the last graph. And so in order to find my x-intercept, obviously my y value was at 0. So I'm going to go ahead and replace 0 in for my y because I know it needs to equal 0. So 5x minus 2 times 0 equals 10. So I've got 5x minus 0 equals 10. So divide by 5 both sides. X equals 2. So my x-intercept is at 2. So 2, 0 is actually where I'm going to find my x-intercept. Likewise, if I want to find my y-intercept, I'm going to replace my x with 0. Got 5 times 0 minus 2y equals 10. So negative 2y equals 10. Divide by negative 2. Y equals negative 5. Okay, so my x-intercept was at the point 2, 0. My y-intercept was at the point negative 0, negative 5. Okay. Find the x and y intercepts. Again, I'm going to find, so to cross my x-axis somewhere, my y value will be 0 because it's not up and down the y axis. It's somewhere on the x-axis, means my y equals 0. So one way of doing that could be something we call the cover-up method. So if I just cover over this, because that basically makes my y a 0, because if I multiply 5 by 0, it's 0. So negative 3 equals 30, or negative 3x equals 30 divided by negative 3, I find that my x equals negative 10. Likewise, and I'm going to erase this for a second. Likewise, I could cover up my x because I'm actually multiplying x by 0 to find my y-intercept. And I see that 5y equals 30. Divide to find that y equals 6. So my x-intercept is at the point negative 10, 0. And my y-intercept is at the point 0, 6. Okay? So find your x and y intercepts. Pause the slide and come up with these on your own. Okay, and so here are my x and y intercepts. X-intercepts at 0.5 and y-intercept is at 0, 2. Okay, so I want to use the intercepts to be able to graph. So I know how to find my intercepts. So remember, I'm going to find my x-intercept by covering over my y. So I get 3x equals 21, therefore x equals 7. So I know at the point 7, 0, that my line is going to cross there. That's my x-intercept. Likewise, I've got negative 7y covering over my x because it's where x equals 0 equals 21. Therefore, y equals negative 3. So I'm at the point 0, negative 3. And I'm just going to draw a really rough sketch here. That's all I'm asking for. So at the point 1, 2, 3, 4, 5, 6, 7, 7, 0. And I'm at 0, negative 3, and I do not have a limited domain. In fact, it's all real numbers, so I'm going to be able to connect these points. Imagine that it actually went through that point, and this is what my line is going to look like that represents this function in standard form. Okay, so let's go ahead and graph this line described by the equation. So how am I going to find my x-intercept? Well, this looks a little bit different than we had it before, so why don't I change it so that it's in standard form? If you want to do it a different way, that's fine, but I'm going to change mine to standard form so I can do the cover-up method again. So I'm going to have 1/3 x minus y equals a positive 2. If you don't know how to do that, go back and watch the video from 2 nights ago. So 1/3 x. Now remember, I can't have a fraction there, so I'm going to multiply everything out by 3. So I'm going to have x minus 3y equals 6. So now I can find my x and y intercepts. My x-intercept is going to be at 6, and so that's the point 0, 6. And my y-intercept is going to be 0, negative 2. And I apologize, I got distracted and didn't pay attention. That was at 6, 0, and if you caught that, good for you. All right. Then I would graph that based on my intercepts. Is going to look like that. My apologies for the horrible graphics. Okay, so let's go ahead and solve this one too. Please go ahead and try this one on your own. You know how to clear the fractions, and I will be back with the solution. Okay, so I've got my x-intercept and my y-intercept. So that's going to look like that. Okay. $75 per hour to produce. The function f of x equals 6,000 minus 75x gives the amount of money left to make the film after x hours of production. Graph this function and find the intercepts. What does each intercept represent? So I need to think about what my graph is going to look like. Well, I know that my independent variable is going to be time, right? Because the cost of the production is dependent on how many hours I spend making the film. So here I'm going to have the amount of money I've spent. Okay, and it says I'm starting with $6,000. Well, if I start with $6,000, then I'm starting up here, and this is my y-intercept. And as time goes on, I'm losing $75 every hour that I've had to make my video. Well, at some point down here, I will have $0 left, right? Oh, sorry, that would be $0 left. And I need to figure out what that time is. I need to know when I've used up my x. So I want to know when f of x will equal 0, and that's going to be 6,000 minus 75 times some number x equals 0. And that's going to be at 80 hours. So at 80 hours, I have run out of money. So my graph is going to look like this. Notice I'm not going to continue beyond that point. That x-intercept that I've got here means that I am out of money at that time, 80 hours, and my y-intercept here told me that at 0 hours, I was starting with my $6,000. Okay, so Trish can run 200 meters in 25 seconds. Function f of x equals 200 minus 8x gives the distance remaining to be run. So I want to graph this function and find the intercepts. I can plug in several points. I know that if Trish hasn't run at all, she still has 200 meters to go. Well, look at that. I've got 0, 200. That means I already have my y-intercept. This is time in seconds. And this is my distance in meters. And I know that at 0 seconds, I have to run 200 meters. So there's my y-intercept. It says that I have 200 meters to run at 0 seconds. Well, I can plug any other number in. Let's see what happens at 4 seconds. Well, at 4 seconds, I've got 200 minus 8 times 4, or 32. So I've got 168 meters to run. So at 4 seconds here, I've got 168 meters to run. Let's say it's here. I could plug in more points, but what happens at, I need to see when I'm going to run all 200 meters. Well, basically, I want to say when f of x equals 0. So if I set that equal to 0, 200 minus 8x equals 0, I find that at 25 seconds. So I know that out here at 5, 10, 15, 20, 25, at 25 seconds, I will have run the entire distance to 0. So I can connect this line when I've reached 25 seconds. I'm going to label my x-axis. This is my x-intercept at 25. So I've got the point 25, 0. That tells me at 25 seconds I have completed the race. And up here, my y-intercept is telling me that at 0 seconds I have run nothing. I have 200 meters to go. So there'll be a post-video quiz posted, and we'll have homework out of the textbook tomorrow. So bring your textbook again, please.